as a recap of what we have covered in this section, a higher level of confidence results in a wider confidence interval, right? So that's where we can look up at what we said here. And as that level of confidence increases, as we go from 68 to 95 to 99.7, notice that the intervals that are created get wider as that increases. If you want to say something with a higher level of confidence, you have to give yourself basically a wider margin of error in order to fall into there. A larger sample provides a smaller standard error and thus a smaller margin of error, and that ultimately results in a narrower confidence interval at the same confidence level. So if I set a 95% confidence level, I can still make my intervals wider or narrower depending on if I take larger samples that would narrow it, or smaller samples would end up with a wider sample. So there are a lot of ways that you can manipulate what your intervals look like based on just things that you choose to do in this creation process, because you get to choose the confidence level if you're actually creating one of these from scratch, and you obviously are in charge of the sample size that you take. Let's look at a question here. Then it says the IPEDS, or the Illinois Post-Secondary Education Data System website, provides a lot of data on colleges and universities in the U.S. A random sample of 35 two-year colleges was taken from this data set, and 2 confidence intervals were calculated for the mean total enrollment of all two-year colleges in the U.S. Both intervals are based on this same sample. So they're both based on this 35 samples. So notice that the CLT is met with this. One of the intervals came out as lower limit 4,948 and upper limit 16,178. Again, these are for the mean enrollment in two-year colleges. And the other one came out as 3,815 to 17,303. And this is all the information that we have right now. The question then is, which interval has the higher confidence level and why? So what we just talked about was a higher level of confidence resulting in a wider interval. So we need to figure out which one of these is wider. You may be able to just look at this and tell. I can look at this and say this second one drops down lower than the first one, and it also reaches up higher than the first one. So if it both drops down lower and higher, it is wider. If you have a hard time just seeing that by looking at them, what you can do is you can subtract to find the width. Just take your upper limit minus your lower limit. So for the first one, I'm going to call it A. I'm going to call this one interval A and this one interval B, just for simplicity. So for A, I could take 16,170 minus 4,948 and find that its width is 11,222. And I could find that the B's width, if I subtract its upper minus lower, would be 17,303 minus 3,815. And subtracting there, I get 13,488. So this one is wider, and that means higher confidence level. The reason I can make this conclusion, though, is because I know that they're both created using the same sample of 35 two-year colleges. Because remember, if we took different sample sizes, that would also change the widths of the interval. So you first have to know that two intervals are based on the same sample, that is held constant, in order to know that the wider one has the higher confidence level. Okay, then part B says, what will be the effect of taking a larger sample, this time of 100 two-year colleges, on the width of these intervals? So if we go back and instead of doing 35, if we do 100 for both of them, then what that should do is it should make both of them narrower. So larger sample should make both intervals narrower. Remember that more information allows you to be more precise and allows you to kind of zone in around that true value better. The true parameter better. And the last question, question number 5 says, 2 confidence intervals were given for the same data. One a 90% and the other a 95%. So again, because it says the same data, we know it was the same sample. So what we do know then is that the 95% interval will be wider. Suppose you want to create a 99% confidence level interval. Well, that would end up being wider than both of the prior, right? Because we're getting an even higher level. But also remember that as you increase that confidence level, your interval could possibly get so wide that it's not even helpful anymore. So what if you want to do this? You want to increase that confidence level, but you want to get a narrower interval than either of the prior 90 or 95% that you already have. How could you change your data collection to do that? So if you want to counteract this confidence interval getting super wide, what you're going to have to do is you're going to have to take a much larger sample. And probably quite a bit, probably a much larger sample to counteract the confidence level making the interval wider. So those two things kind of work against each other, and when you're in charge, when you're actually the data collector, you really have to kind of work those two things against each other to create confidence intervals that you desire, to give you the most information that you can at the highest confidence level before, again, making it so that it's not really helpful because it's too wide.